Hi students, I want to welcome you once again to our lesson for today. We are going to be looking at numbers 17 and 18 in this lesson, and the questions numbers 17 and 18 are gotten from our WASSCE 2020 mathematics questions, and I'll be providing you with the answers in this lesson. You are welcome to Math Fusions. My name is Justice Johnson. This is the channel where you learn maths the easy way. If you are just joining us for the first time, please consider subscribing so that you can help us to build this channel to reach out to many people who have deficiencies in mathematics, so that through the problems being solved here, they can be able to improve in their skills in solving mathematical problems. So if you are ready for this lesson, let us dive into it. Now, if you take a look at the question here, question 17, if you take a look at this triangle, the question says, from the diagram, which of the following is correct, is true? Which of the following is true? You can see the options for A, B, and C. Now, for us to answer that question, let us take a look at the diagram. You can see that this is a triangle whose ends have been projected to form two external or exterior angles, S and T. So where do we start solving this problem from? Well, for us to solve this problem, let me first of all come here and write here as E, then I'll write here as F. Okay, now let me letter these two parts this way. What we are going to do now is this. We are going to, if you observe E and S, there's a relationship between E and F. What is that relationship? E and F, and S, if we sum them both up, they're going to give us what? 180 degree. So let's start up with that first of all. So we can come here to say E plus S is equal to what? 180 degree. That is angles on a straight line. Now, if that is the case, then our E is going to be equal to 180 degree minus what? Minus S. So take note of this. Let's just call it equation 1, all right? Now, we come back to the diagram. We put the value here. So our E is the same thing as 180 degree minus S. We do the same thing for F and T because both of them are on the same straight line. So we can come in here to say that F plus T is equals to what? 180 degree. That is the same reasons, okay? Angles on a straight line. So from here we can get our F to become 180 degree minus T. Now the reason why we did that is so that we can get the three angles that are inside the triangle. So which means over here I'll come to write 180 degree minus T. So your 180 degree minus T is the same thing as F, and your 180 degree minus S is the same thing as E. So now we've known the three angles in the triangle. What next we are going to do is to add the three of them up, and the total sum of angles in the triangle is what? 180 degree. So we are going to come here and then we'll write it down here. We say that our R plus E plus F is equal to what? 180 degree. That is angles in a triangle. This symbol is short for triangle. Now, what do we have there? We have our R plus E. E is equal to what? 180 minus S. You write it out. 180 minus what? Minus S. 180 minus S. Then plus F. F is what? 180 minus T. So write it out. 180 minus T. And all equals to what? 180 degree. So here's what we are going to do now. If we come to this place here, we are going to write this our R minus S minus T out. We are writing it out as R minus S minus T. Then we are summing up our 180 plus 180, and that will give us plus what? 360 degree, then equals to what? 180 degree. Now in this case, now what do? We see right at our R minus S minus T, then plus 360 degree. Then our 180 degree, we are going to move it to this side. We are crossing the equality sign. It will change from positive 180 to negative 180. So we have minus 180 degree, all equals to 0. So if we simplify this, we are going to have r minus s minus t, then plus 360 minus 180 will give us 180 degree, then all equals to what? To 0. If you observe, you realize that our minus s and minus t, we are going to move both letters to this side, from the left side to this side, and their signs will change to the opposite. So which means we can say therefore on the left side we are going to have r plus 180 degree to equal, when our s comes here it becomes positive x, when our minus t comes to the other side it becomes positive what? T. So this is what we are going to have. We are going to have this as our answer. R plus 180 degree equals to what? S plus T, which now brings us to the options that we have here. Okay, you can see that A will now be the right option for this question. I'm sure you understood everything that has been explained and you are following me in this explanation. Please, I want to encourage you to watch all the videos in this series of WASSCE 2020 mathematics questions and answers. And as you continue watching them, you can pause the videos to practice them on your own. Now, having said that, let's quickly dive into question 18. Now, question 18 is a very interesting question. And in a short while, you are going to see the reason why I said so. Now, here it says, calculate the number of revolutions a bicycle wheel with radius 35 centimeter will make in order to cover a distance of 330 meters. Then we are asked to take the value for pi as what? 22 upon 7. Now, what are we going to do in this case? First of all, we are going to draw we are going to give a visual diagram for this particular question. The question says calculate the number of revolutions of a bicycle wheel. So I'm going to draw a rough sketch of the bicycle. This is a bicycle wheel, okay? And the bicycle is moving on the horizontal floor. This is the horizontal floor. Then we know that the bicycle has 2 wheels. And we can do this and possibly bring this up here this way, and we do this, all right? Then the pedals could be somewhere here, something like this. Then this could be the handle, all right? Okay. Funny bicycle, isn't it? Now, if we take a look at this is bicycle, okay? Now, let's get serious. Yes, it's calculate the number of revolutions. Now, when we say the number of revolutions, we are talking about the number of times which this wheel will turn round. And you know that as the wheel of the bicycle is turning round, it will be moving forward this way, okay? So, which means the direction of the movement is going this way. So the number of revolutions we don't know, we can represent it as n. Okay. Now it says calculate the number of revolutions of a bicycle wheel whose with radius 35 centimeter. Now the radius of the bicycle is what? 35 centimeter. So from this distance here to this distance is what? 35 centimeter. We have to represent it there. Okay. So the radius r is what? 35 centimeter. And then we are told that the distance which the bicycle wheel covered is what? 330 meters. So we have the distance d to equals to what? 330 what? Meters. And then we are looking for the number of revolutions which we can do this. Okay, now, having done all of this, what we are going to ask ourselves now is, how are we going to get the answer? It's very simple. We come to the wheel. You know the wheel is turning round, okay? And from what I just said now, the distance round the circle is known as what? Circumference. And we know that our circumference has a formula of 2 pi r. So this is the formula we shall be using, okay? So which means the wheel will turn round for n number of times. So to get the total distance, therefore, we can say n multiplied by circumference, n multiplied by circumference of what? Of circle. Okay, and that will give us what? Distance. That will give us the distance what? Covered. Alright, I'm sure you understood what I did there. Okay, the n is the number of times this wheel will have to turn round. Okay, that's the revolutions they're talking about. The circumference of the circle is the distance around the circle, because it is the distance around the circles that goes round, and the formula for it is what? 2 pi r. So which means we are going to come here to say n multiplied by 2 pi r to become the distance d. Alright, so what we do here now is to slot in all the values that we have. So for our n, we retain it because that's what we're looking for. Then we write our 2. Then for the pi, if you check the question, pi is a constant and it is given as 22 upon 7. So here we are going to write what? Multiply by 22 upon 7. Then multiply by the radius, which is what? 35 centimeter. Then equals to the distance, which is what? 330 meters. Now before we continue, I want to draw your attention to what I did. I purposefully wrote this up to this point here, okay? And if you check, the radius is what? 35 centimeter, while the distance is in meters. You cannot work with different units. So all you have to do is to convert your 35 centimeter to meters so that you can have the same unit, okay? So in doing so, we have to divide this 35 by 100 to convert it to meters. So which means here we'll come to say n multiplied by 2 multiplied by 22 upon 7 multiplied by 35 upon 100 meters, then equals to 330 meters. So the meters can cancel the meters, right? Now, if you check up here, you can see that 7 can cancel 35. How many times? 5 times. So at the numerator, we are having 2 times 22 times 5, then times n. 2 times 22 is what? 44. And 44 times 5 will give us, this will give us 0. Then let's put our n. Then we have 220. So 44 times 5 will give us 220 times the n. We have 220n. Then equals to what? What we have here is what? 330. But let's come back to this place here. You can see that the 100 is still here. We didn't do anything with the 100. That means while we are multiplying the numerators, the 100 should come under what we are doing here, okay? 220n upon 100. So this, we cancel this. Then we'll be left with 22 upon 10. Cross multiply so that our n, in this case, will become 330. The 10 is coming to multiply this times 10. Then divided by what? The 22 is coming down because this is cross multiplication. Now, in doing this, 11 can go here 2. 11 can go here 30. Then 2 can come in here 1 and come in here 5. So we have that n becomes 30 times 5. And 30 times 5 will definitely give us 150. So the number of revolution which the wheel of the bicycle will turn around is what? 150. So there you have it. That is the end of the lesson for today. I'm sure you enjoyed this class. Please, I want to see you in my next class. We are still going to continue with our WASSCE 2020 mathematics questions and answers.